Hello everyone, so today we have the following trigonometry problem. Evaluate the expression 4 sine of 105 degrees times the cosine of 105 degrees plus 5 minus 10 times the sine of 15 degrees all squared using double angle identities. Alright, so let me write down, sorry, these are already written down. Let's look at the double angle identities here for sine and cosine. So sine 2 theta is equal to 2 sine theta cosine theta. So the double angle for sine is just 1. For cosine, there's 3 versions of it though. Cosine 2 theta equals 2 cosine squared theta minus 1. Also 1 minus 2 sine squared theta. And last but not least, cosine squared theta minus sine squared theta. So the way these questions work is by looking at the expression that's given and see if you can try to match up that expression to an identity, okay, and to some extent. So let me start by looking at the first part, which is that 4 sine 105 degrees times the cosine of 105 degrees. And let me go ahead and just paste this real quick. Here we go. And I'm going to ask myself, does that expression look anything like one of my identities? Yeah, and it does look like the sine of 2 theta, okay? Except the sine of 2 theta only has a 2 in front of the sine and the cosine. Here I have a 4, not a 2. But here's what I can do. I can rewrite this 4 sine theta cosine 105 as 2 times 2 sine 105 times the cosine of 105. So the big deal here is you try to make your expression look like or match up to the identity by doing algebra or by doing arithmetic backwards in a sense here. So that's what we do. We'd simplify using that. And now that I see this, I recognize that 2 sine 105 times cosine 105 is now the double angle identity. And by that double angle identity for sine, this is going to be 2 times the sine of twice what 105 is. And all of that would equal 2 times the sine of 210 degrees, okay? So all of this right here just became the sine of 2 times 105, which is the sine of 210. And I can figure out the sine of 210, and we'll do that in a minute. Now let me, though, go back to my other part of the expression, which was the 5 minus 10 sine squared 15 degrees. Let me copy that. And paste. And we'll go ahead and work with this as well. And yeah, this does not look like this sort of looks like the second identity, the 1 minus 2 sine squared, except I have a 5 instead of a 1 and then a 10 in front of the sine squared instead of a 2. But again, I can use a little bit of algebra here by factoring a 5 out. By doing that, you get 5 times 1 minus 2 sine squared of 15 degrees. And by the double angle identity of cosine, that's going to equal cosine of 2 times 15 degrees, which becomes the cosine of 30 degrees. Okay? And now I'm at a point where I can figure out the sine of 210 and the cosine of 30, because those are angles that we know on the unit circle. The sine of 210 is minus 1/2. And the cosine of 30 is root 3 over 2. And furthermore, 2 times minus 1/2 is minus 1 plus 5 root 3 over 2. Okay. All right. So that's the big deal with these expressions in the sense of, yeah, you have an expression and you want to try to find the exact value, but it's a matter of matching up your expression to an identity. And you have to often do a little bit of algebra in order for you to do that, or whatnot. It could be something else. But yeah, often algebra, you have to simplify, is what I'm trying to get at to get your exact expression. Okay, thank you for your time. Hope this helps.